Mission Impossible Lab is one in which you will be developing your own procedure and trying to identify an unknown from calculations based on a concept that is called stoichiometry. And in a nutshell, stoichiometry is a process where if you use two things, your knowledge of how to go from grams to moles and your knowledge of what the coefficients in the balanced equation mean, you can actually predict the mass of product formed from a certain amount of reactant. So in this experiment, that's what you're going to do, predict ahead of time the mass of products formed from a given amount of reactant. So let's begin. The first unknown that you have three unknown possibilities, and the three of those are, the formulas are listed here. Notice that what they have in common is the carbonate aspect of their formula. In this lab, if you read the Mission Impossible handout, why don't you pause the podcast and read it? If you haven't read it yet, the rest of the podcast is going to move too quickly. So pause the podcast, read over the lab first, and then come back, or you'll be confused. So, as you've read in the procedure, you'll be reacting the carbonate, your unknown, with hydrochloric acid. Hydrochloric acid, you know the formula of it, and if you remember from our study of types of reactions, you probably would be able to identify that this is not only a double displacement reaction, but a gas-forming one. So stop for a minute and look at those three unknowns and try to write an equation for each of the unknowns reacting with hydrochloric acid. Again, the unknowns are KHCO3, sodium carbonate, monohydrate, and strontium carbonate. Try to write a balanced equation. Pause the podcast and come back to it in just a moment. So in this example, which is not one of your unknowns, I'm reacting aluminum carbonate with hydrochloric acid. And again, when we write the products formed and we use formula writing skills that we learned a few chapters ago, we have aluminum chloride is formed. We could look up its solubility and conclude that yes, it is soluble in water, and it would form carbonic acid, but we know that carbonic acid decomposes into CO2 and water. So on the product side, I'm going to put that, CO2 and water. If I were to go ahead and balance this equation, I'll put a 3 here, 3 carbonates, and then I'll have to put a 6 here, 6, and then a 3 here. So I believe that would be correct. So we have a balanced equation. That's the first step, is to write a balanced equation. Do that in the same fashion for all three unknowns. Double check. Notice something about the products formed. In each case, carbon dioxide and water will be formed, and then also a soluble salt. So after we've written a balanced equation, next I want you to make a list of the products to be isolated. Remember, when we're doing problems like this, it's important to recognize your given and what you want. So making a list of the product to be isolated is the next step. So go ahead and pause the podcast again, make a list for each unknown of the products isolated. So if you were to look at this here, this is the reactant. That will be your given. And so what is the product that you will actually isolate in each case? That's the goal. Okay? All right, so once you've identified the product to be isolated, the next step is to calculate the moles of reactant that are in 2 grams. So in this lab, you're actually all going to use, and this is one of the rare cases, where you're going to use exactly 2.00 grams of the unknown. In every case, you're going to take the extra minute or two necessary to measure out exactly 2 grams. And that is important so that when we predict ahead of time today the mass of the product formed, we can assume that that is the mass of the reactant that we are going to use. And my question to you is, and this is something for you to ponder as you develop the procedure, why is the amount of hydrochloric acid that you're using in this lab not relevant to the mass of the product formed? So for this calculation, we know that we're starting with 2 grams of aluminum carbonate. So let's put that up there as our given, 2.00 grams of the unknown. So if my unknown was aluminum carbonate, and I don't know ahead of time what my unknown is, I just have to prepare ahead of time and do calculations for every possible unknown listed. Okay, so if we know our unknown, we have to figure out what it is that we're trying to calculate. Well, if you look at it, what we're trying to calculate eventually is the mass of product formed. So the question is, which product, since there were 3 of them? Well, it is going to be the salt that's left in the equation that we're going to calculate, because the CO2 and water will be able to get rid of those from the equation, from the container. So what we want to find is the mass, in this case, for this unknown, aluminum chloride. So now what we're going to do is calculate the moles of reactant in 2 grams. So I've taken the liberty of calculating ahead of time the molar mass of aluminum carbonate, as you can see. So taking the molar mass of aluminum carbonate and using that to convert grams to moles, I know that there are 233.99 grams aluminum carbonate in 1 mole of aluminum carbonate. Take the time to write the formula of each reactant as well. Performing the calculation gives you 0.00855 moles of aluminum carbonate. So knowing the moles of the reactant, we can then move to understanding the moles of the product formed by using the balanced chemical equation. So let's go to that equation and see the relationship between aluminum carbonate, which is our reactant, and our product, aluminum chloride. So we want to know, what is the mole ratio? What is the mole ratio between aluminum carbonate and aluminum chloride? Well, we use the coefficients. Remember, the coefficients in the balanced equation are like the proportions of reactants to each other and to the product. So aluminum carbonate, 1 mole of aluminum carbonate reacts with 6 moles of hydrochloric acid to produce 2 moles of aluminum chloride. But since the water and the CO2 left, the coefficients in this case in front of the CO2 and water aren't so important to us. So our attention is focused on the fact that we are going to look at the mole ratio between aluminum carbonate and aluminum chloride. It is a 1:2 ratio. So if we go back to that equation now, we're going to compare the mole ratio. Remember, it was 1 mole of aluminum carbonate reacts with every 2 moles of aluminum chloride formed. So I'm going to take my moles of aluminum carbonate that reacted, 0.00855 moles aluminum carbonate over 1, and then I'm going to multiply by the mole ratio. So the ratio in the balanced equation, remember that ratio is here. 1 mole of aluminum carbonate goes in my denominator here, cancel, for every 2 moles of aluminum chloride. We're using the coefficients in the balanced equation to do this calculation. Do the math, and of course you'll have 0.0171, did I do that math correctly, moles of aluminum chloride. Our final step is pretty simple. Once we know the moles of the product formed, then we can go and calculate the mass of the product formed. That is called the theoretical yield. That assumes that everything goes perfectly in a lab. And of course we know how that is, but the point is we're doing a calculation to predict the mass of the product formed. And so I take my moles of aluminum chloride that I've calculated, 0.0171 moles of aluminum chloride, and how do I go to grams? Oh yeah, we know how to do this, right? I look up the molar mass of aluminum chloride, calculate it to be 133.33 grams of aluminum chloride. Doing the math then gives us a predicted mass of product of 2.28 grams of aluminum chloride. Again, this is the mass of the product formed, assuming the reaction goes perfectly, assuming that what we've done is reacted 2 grams of aluminum carbonate with enough HCl so that all of the aluminum carbonate reacts. If that is the case, then the mass of the product formed, if aluminum carbonate were my unknown, is 2.28 grams. So you'll be doing that same process for all 3 of these unknowns. Using 2 grams of the unknowns, calculating the molar mass of each of these unknowns. Little hint, remember how you calculate the molar mass of a hydrate. A little hint there, don't forget to consider the water in your calculation. So before you come to class tomorrow, read over the lab calculations that you are to do. Make sure you bring in the procedure, the data table, remember to title the data table, etc., as we've discussed, and print out 2 copies for lab on C-Day. Have a good day.